So today we'll do some exercises from the book, the chapter, from the fifth chapter. So the first one is a wire has a measures L meters. So we have a wire and it measures L. So measures from here to here. This is L, okay? And it will be cut in two pieces. With the first one, it will be made a circle, and with the other, a square. So with this L, we're going to do a square and a circle. Okay. Okay. And it says, where should we cut the wire so that the sum of the two areas of both figures are the minimum? So we want to cut L so that the area of the square plus the area of the circle is equal to a very low number. Let's say 1/1000. Just for a number that is low. Okay. So let me put that in the math. So we have over here. So if we let's say that I cut the L on this place here, which is so from here to here is X, and from here to here is L minus X. Okay. So let's say that with the X part, I'm going to do the circle, and with the L minus X, I'm going to do the square. Okay. The square is this part, and the circle is this part. So what is the circumference of the circle is equal to this part here, which is X. Okay. Circumference. And the perimeter of the square is 4 times the side, or the perimeter is the other part, which is L minus X. Okay. So I know that the area of the square, let's say area of the square, that's equal to the side square, right? So that's the perimeter, and we have 4 sides. So if we divide the perimeter by 4, so we have to do on the other side, the perimeter divided by 4, that's equal to side, okay, or L. And if we raise that to the power of 2, right, then that's the area of the square. So the area of the square is equal to L minus X squared divided by 4 squared, or 16. Okay? That's the area of the square. And we know that the area of the circle, that's equal to pi r squared. Okay, pi times r squared, or right, it's pi times d over 2, right? This is the radius, all of these squared, or b times d squared divided by 4. Okay? And we know the circumference, and the circumference is or better, d, which is the diameter, actually c divided by the diameter, that's equal to pi, right? So c is equal to d pi. So actually d, that's equals to c, which I know, over pi, or 2r, could also be it can be 2r, 2r, and then I divide by 2 on both sides, gives 2 pi. Okay. So the area of the circle, that's equal to pi squared, pi times r squared, which is c over 2 pi. And all of this is squared. But what is c? C, which is the circumference, is x, right? So that's the same thing as x divided by 2 pi, everything squared. And now we want to know the total area. AC plus AS, the area of the square plus the area of the circle. So the total area is equal to AC, which is pi times x squared divided by 4 pi squared plus the area of the square, which is L minus x divided by 16. Okay. So we know that we can cancel this out. So take this out and this out. And we are left off this. Let me pull this a little bit back. So squared here. Okay, so we have that. And this is a function, right? AT in function of x. So that is equal to this, okay? So let's say that this function is something like this. We have two x's, right? We have the total area and x, okay? So let's say something like this. I don't know. Actually, it wouldn't be like that. It would be something like this, okay? Say something like this, like a sign. So if we take the derivative, we're going to see that it begins rising, it goes 0. Now it gets negative, 0, positive, 0. And the zeros, where the 0 are, that's the minimums and maximums. So if we take the derivative, dA dx, and that's going to be the derivative of this AT, the derivative. And I equal this to 0, I'm going to find the maximums and minimums of this. So if I encounter one of these, I can know in which x I need to cut so that I get the maximum or the minimum, okay? So let's take the derivative of a in relation, right, to x, because my function is a in relation to x, okay? E x. So that's going to be equal to what? Let's see our function. Our function is x squared over 4 pi. What's the derivative? X squared divided by 4 pi, that's the same thing as 1 over 4 pi. That's a constant times x squared. So I take that 2 back. So that's the same thing as 2x. Okay. And I multiply. I can even cut this with this. Okay. Now it's x over 2 pi. Okay. Plus. Now I have L minus x over 16. Okay. So I'm going to take the derivative of this, which is 2 L minus x, okay, times the derivative of here, which is negative 1. So that everything divided by 16. So that would be L over 4, okay, minus x over 4 squared, right? And so this over here should be 2 factor of L minus x divided by 4. And this down here, okay. Squared minus x minus. This here's a constant, so it's 0. So it's minus 1/4. Actually, that's times. So that would be 16 times 4. So it would be 2 factor of L minus x over 16 times 4. This is summed with x over 2 pi. And it is a negative. Negative over here. Negative over here. So now we equal everything to 0. So we have x over here and x over there. We do x over 2 pi plus minus x over, the x is positive, plus x over 16 times 4 less minus 782 minus 2L over 16 times 4. Okay, okay. That's equal to 0. So what we're going to do is put the x in evidence. X is 1 over 2 pi plus 2 over 16 times 4, okay, minus 12 over 16 times 4, right? That's equals to 0. Okay, so we take this to the other side. 2 over L times 16 dot times 4, right? Multiplied by 1 over 2 pi plus 2 over 16 times 4 and -1 that's equal to x. So let's do this sum. Oh, 16 pi. 16 pi divided by 2 pi, that's equal to 8 plus 16 pi divided by that is 4 pi times 2 is 8 pi. And then we multiply this 2L over 16 times 4, okay, times 16 pi, because it was on a -1, over 8 plus 8 pi. So this cancels out, this cancels out, and L times pi over 4, factor of 4 plus 4 pi. And it is wrong, and I know why. So I had a little problem in the derivation, the derivative, uh, because I tried to go faster than I could. So my error was that I didn't did the derivative correct. So I'm not going to open any brackets, okay? So A, so the derivative of A in relation to X, it's the derivative of L minus X divided by 4, okay? Everything squared plus we had X pi times 2 pi times X over 2 pi, okay? Everything squared. That was the original. Now we're going to take the derivative. So that's the same thing as 2, right? The derivative of the outer, which is 2 times the brackets, 2 times L minus X over 4 times the derivative. L over 4 is a constant, so it's minus 1 over 4, right? Plus X squared, so it's 2x, over 4 pi squared, and the pi squared, they cancel out. So 4 pi, cancel, cancel. So it's x squared over 2 pi. Good, good. Cancel and cancel. So it will be 2 times 4 is 8. Okay, so this is going to be what? L minus x over negative 8, okay, plus x squared over 2 pi. So, oh, no, 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 it's not x squared, it's 2x, 2x, okay, 2x. And then I cancel what they want, so it's x over 2 pi. I almost got it wrong. Okay, 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 now it's right. So, going to be, I can separate it. So it's going to be L over negative 8, and then minus x over minus 8, which is x over 8, right? Negative can cancel out. X over 8, okay, plus x over 2 pi. And we equal this to 0. Now it's going to be, now it will be right. So we take it to the other side. So it's L over 8. Now everything positive. That's equal to x in evidence, right? X factor of 1/8, 1 over 2 pi. I could just multiply it, but I know that I've done this multiple times, the same exercise. So that's equal to 8 pi. Then 8 pi divided by 8, that's equal to 1. 8 pi divided by 2 pi, that's equal to 4. Pi plus 4, okay. So then we'll multiply L over 8. Then we multiply it. So it's going to be L over 8 times 8 pi over 4 plus pi. Right? 8 pi, or actually I could just multiply it. It would be 16 pi. So if I multiply it, it's going to be 16 pi, right? Divided by 8, that's 2 pi, plus 16 pi divided by 2 pi, that's 8. And if we multiply, then it gets, that will be equal to 16 pi over 8 plus 2 pi. So it's 1 in here, 2. So it will be 2 pi times L over this L over here, okay, over 8 plus 2 pi. We can divide here, so 4 plus pi, and then pi L. Pi L. 2 pi L over 4 plus pi. And the same thing I have done wrong because I did this only for 1. So we had L. And again we go L minus divided by 4 squared plus pi times x over 2 pi squared. That's going to be equal to what? 2 times x over L minus x over 4, okay, times that, negative 1 over 4, plus 2 pi times x over 2 pi, okay, plus the times the derivative, which is 1 over 2 pi, okay. So it goes L minus x divided by 2, is 1 over 4, okay, plus 2 pi, so x divided by 2 pi. L minus x over 2 p times L minus x. Okay, okay. So now it is L minus x over 8 plus x over 2 pi. And that's the same thing. We had L minus x. So okay. So we had once more L minus x over 2 pi plus that's equal to x over 8. So L over 2 pi minus x over 2 pi. That's equal x over 8. Okay, and now we sum x over 8 plus x over 2 pi and gives us this L over 2 pi. That's equal to x over pi. Pi plus 4 over 8 pi. And now we multiply 8 pi L over 2 pi factor of pi plus 4. 8 cancel with 2, pi with pi. 4L over 4 plus pi. And here we have the answer. The next exercise, I hope, gets faster. So, how should we cut the wire so that the sum is the maximum? So, the maximum is a circle, right? With the minimum radius, you can have the maximum area, okay? So, L, if L is the circumference, circumference, that's equal to 2 pi r, right? And so that's L equal to pi r. So r is equal to L over 2 pi. That's equal to r. The area is pi r squared. So pi times r all over 2 pi squared. That's equal to the area of the circle, which is the maximum area. And so 2 r squared over 4 pi squared, which cancels with this. That's the maximum area. L squared over 4 pi. Let me see, incorrect. And okay, L squared. But on the we saw that L for x, right? That's equal to 4L. So it's 4 L over 4 divided multiplied by 1 over 2 pi. And this will multiply by pi. So bam, L times pi, okay, divided by 4 plus pi. That's the area, the maximum area. Yeah, that's it. So both answers are L pi over 4 plus pi, and the other one is 4 pi, 4L over pi plus 4.